The term solar panel is used colloquially for a photovoltaic (PV) module. A PV module is an assembly of photovoltaic cells mounted in a framework for installation. Photovoltaic cells use sunlight as a source of energy and generate direct current electricity. A collection of PV modules is called a PV panel, and a system of panels is an array. Arrays of a photovoltaic system supply solar electricity to electrical equipment. The most common application of solar energy collection outside agriculture is solar water heating systems. Each module is rated by its DC output power under standard test conditions (STC). Power typically ranges from 100 to 365 watts W. The efficiency of a module determines the area of a module given the same rated output. An 8% efficient 230 W module will have twice the area of a 16% efficient 230 W module. Some commercially available solar modules exceed 24% efficiency. Most solar modules are currently produced from crystalline silicon (CC) solar cells made of multicrystalline and monocrystalline silicon. In 2013, crystalline silicon accounted for more than 90% of worldwide PV production, while the rest of the overall market is made up of thin film technologies using cadmium telluride (CIGS) and amorphous silicon. Emerging third-generation solar technologies use advanced thin film cells. They produce a relatively high efficiency conversion for the low cost compared to other solar technologies. Also, high cost, high efficiency, and close-packed rectangular multi-junction (MJ) cells are preferably used in solar panels on spacecraft, as they offer the highest ratio of generated power per kilogram lifted into space. MJ cells are compound semiconductors and made of gallium arsenide, gallium-3 arsenide, and other semiconductor materials. Another emerging PV technology using MJ cells is concentrator photovoltaics (CPV). In rigid thin film modules, the cell and the module are manufactured in the same production line. The cell is created on a glass substrate or superstrate, and the electrical connections are created in situ, a so-called monolithic integration. The substrate or superstrate is laminated with an encapsulant to a front or back sheet, usually another sheet of glass. The main cell technologies in this category are cadmium telluride, or a C plus UC tandem, or CIGS or variant. Amorphous silicon has a sunlight conversion rate of 6 to 12%. Flexible thin film cells and modules are created on the same production line by depositing the photoactive layer and other necessary layers on a flexible substrate. If the substrate is an insulator, e.g. polyester or polyimide film, then monolithic integration can be used. If it is a conductor, then another technique for electrical connection must be used. The cells are assembled into modules by laminating them to a transparent colorless fluoropolymer on the front side, typically ETFE or FEP, and a polymer suitable for bonding to the final substrate on the other side. Several companies have begun embedding electronics into PV modules. This enables performing MPPT for each module individually, and the measurement of performance data for monitoring and fault detection at the module level. Some of these solutions make use of power optimizers, a DC to DC converter technology developed to maximize the power harvest from solar photovoltaic systems. As of about 2010, such electronics can also compensate for shading effects, wherein a shadow falling across a section of a module causes the electrical output of one or more strings of cells in the module to fall to zero, but not having the output of the entire module fall to zero. Please subscribe, like, share, comment, and click bell icon for upcoming videos.